Welcome back. This is Loudon Gaming, continuing my sand simulation, particle simulation in Unity. Last episode we made lava, and this episode we're going to be making gas. I've already created the script here. The gas, we're just going to work on this. Like always, it needs to inherit from the cell. Get rid of all this stuff there. Let's get that constructor here. All right, we're going to say color is equal to color white, maybe, I guess. Or we could do like this, actually. Let's say new color. Oh, you know what? I think anyways, this really should be between 0 and 1. So let's say 0.75f, comma, 0.75f, comma, 0.75f. So not quite white. Uh, can burn will be false. And is there anything else? Oh yeah, we should do the cell type is equal to gas. Whoops. I would say cell type. I don't have that yet, so let's add that. So, and I think in the last episode, maybe I didn't add that to the lava. So this should be uh, gas. Just check lava. Did I do that? I did do that. Okay, so gas. This is going to be cell type dot gas. Let's see. Is that all I need? Can burn color. Okay. So then we need to override the active. Now, this will just check up. Uh, if let's see if I can remember. Check position. Check placement. We're going to check the placement of the up position, and we're going to say true. So replace it. So this should make it just go up. Now we would say not here if it wasn't, and then we do some more logic. But let's just see if we can get gas going up in the air. Let's go to our simulation and add that to this here. Again, it would be probably better to write code that could automatically do this. Gas is equal to new gas, and we want to call it the position. This is again just for adding cells to add gas, just like that. All right, let's see if we can at least add the gas on our own. So let's switch to gas. Nothing's happening. Okay. Let's see if we can add gas now. All right, we are adding gas, but it's not moving. So, and we might want to change the color a little bit. So let's see what's happening here. All right, so we did not set the direction. So again, I wish I could have these things more automatic. Anyways, it might be that I have to always leave that base activation, and maybe we just put it in the cell. All right, here's our gas. There we go. It's going to the top, and it'll just stack up for now, but we're going to make it more like water. All right, so in here, we basically want to steal the water logic and let's just copy all this and see if this will work the same way. So basically, we're going to check if we can go to the left or to the right. If we can, then we're going to randomly pick one of those directions. All right, let's switch to the gas. Whoops. All right, there we go. It's filling up in the top. Let's just see what happens if we add some walls here and add some gas. Cool. So now we have gas particles going up in the air. All right. So now we can fill up the top if we want to. Let's do some more walls here. There we go. Now we can fill this area here, and then it kind of spills over there. All right. We might want to do some other things to make this a little bit more like, you see how it just kind of goes straight up. Maybe we could randomly move its position each time. So let's see about how could we do something like that. All right, so let's think about this. Right now, this is checking if we can go up. And if we can, we're going to let's redo this, okay? So let me just go to this code. Let me just go to the definition. What this is saying, if we're saying, is it placing? So this is what the Boolean is. Are we going to place it? Maybe we don't want to place it right away. So maybe what we do is gas. Maybe we want to check, do something like this instead. So we're going to have a, let's see, we we kind of want another like possible locations. So we're going to say up possible locations. Sorry, list vector twos, and we would say up possible locations. So we're going to do this. And then what we're going to do is kind of like what we do with the water here. We want to check the placements. So I'm going to say if check placement for up, comma false. We don't want to replace it. We just want to check to see if we can. And then if we can, we're going to say up possible locations dot add. We're going to add up. All right. And then we're going to do this for, I'll just copy and paste. Yeah. We're going to do this for the up left and up right. Again, I already have these in the cell. We did that last time. We already have all of these directions, and the set direction is getting those positions. So makes it a little bit easier. And we don't have to retype things over and over again. So now we've added these to the possible locations, and then we're going to just do kind of like what the water does. We're going to copy and paste this here, but instead of doing the and we'll change that to up. All right, so we're going to randomly pick one of these three choices that we can go to. Now, we're going to get rid of this here, and we'll do an else statement here. And then let's just copy all that, get rid of this extra bracket there. So if we can go up, if we have a possible location, whether it's up, to left, to the right, somewhere, we're going to do that first. And then if we can't go into any three of those, then we're going to start moving side by side. So let's see if this works. All right, cool. Look at that. Yes, that's kind of what we want. We just want them kind of randomly going up in there. Whoops, we got out of bounds. Uh-oh. All right, I think I noticed where I had a mistake. I had this as up instead of upright, so I forgot to change that. So hopefully this will uh, change, maybe. Yeah, because hopefully this is what was the problem. Okay, now we're filling that up. Don't seem to be getting any errors. So I think we have it. And again, we could do, these walls. This might be interesting. See what happens here. Since we have a little, yeah. Oh, what in the world? It's taking out the wall. Okay. Um, so in one of the directions, it's thinking, uh, hmm. All right, something else to fix. All right, so I've been trying to test this out, and I don't know why it was removing it, and I can't seem to replicate it again. Um, so I kind of changed the pixel color to white. If you're wondering why it's not like exactly like very bright white, is because this is a 3D environment and there's a lighting system. So it's probably why it's not as bright, but I'm not getting what I thought I saw before. Maybe I was just not seeing it correctly, but I'm not getting the like removing of these. I didn't change anything, so I'm not sure why that was doing that. But anyways, we'll move. We'll just move on. But maybe we want to now have it interact with water. What happens when lava hits water? All right. I'm not sure how this is going to work. Again, I'm not really like looking up any kind of tutorials or how this is how you should program gas and these kind of simulators. I'm just kind of seeing if I can kind of just figure it out on my own. Um, but basically, what I'm thinking is when we get to this point here and we're checking burning, we want to check if the cell is water. If cell is dot cell type is equal to water, we want to do something. All right. If not, we're going to start burning it. So water is going to instantly burn. All right. So whoops, how do we want to do this? Whoops, burn it. How do we want to do this? We basically want the cell to be removed. Um, simulation dot instance dot cell to remove, and we're going to remove um, the cell. Whoops. Dot remove cell. So we want to remove the water, but maybe before we remove the water, we're going to say simulation dot instance dot add. We're going to add a new cell and the cell position. Using the position of the water that's being burned, we're going to now add the cell type of gas. Whoops. So we're going to add a gas particle there. So let's see if this would work. So again, in our check burn function, uh, if we get to a cell that is water, then we're going to do this, which is going to add a cell of a gas where the current water position is located, and then we're going to remove that cell. But if it wasn't water, then we just burn it like normal. All right, we're first going to test this with water on the bottom, and then let's drop lava on top of it. Do we want to do that? All right, it did remove it. Okay, we are instantly removing the water. Let's fill this up with the lava and see what happens if we place water on top of the lava. All right, we are not adding a, we are not adding that. All right, let's see if there's something wrong with our code. All right, so I figured out what was the problem. When we add a cell, it first checks to see if there is nothing in that grid. If there's something in that current grid position, it's not going to add it at all. It's going to just return it. So in my lava code, I was I was removing it, but it doesn't get removed instantly. So there was still something in the grid where the water is and where I want the gas. So I want the gas to be where the water is, but since the water is still there, it wasn't adding the water at all. So what I did in the lava is I basically added this code right here to just get that grid position just set to null so that we will get rid of the grid, get rid of that water from the grid immediately. And then we can just add that water to, so it basically becomes empty. Now, I could see this being a problem maybe later in the code or something, because the way that the simulation being run right now. If I were to make the simulation maybe a little bit better, I would have like a previous state of the grid, and so any new changes would be made to a, new grid, um, and not affect the old grid, because right now it's going through like a top-down approach to when cells were created. So if one cell was made before the other one, it's going to run its code first. But anyways, we'll just see if this works. All right, so um, let's add lava first. Let's see if we can get some gas. So there's the lava. Let's add water. Oh, and there, yep, there you go. It's making gas. All right. So that seems to be working. Now, what if we did it the other way around? Let's make our walls here. I think what I'll do is maybe make walls not burnable, so you can just hold uh, lava in it. But let's add water first, and let's put cool. Uh, that's really cool. Let's add lava to this. See what happens. Oh, whoa, that's cool. All right. It kind of, ooh, that's so cool. Let's just let's start it over. All right, so we're going to just add water to our bottom scene here, and we're going to add lava. And I don't know if this is going to like slow down our code when we add lava on top of this. We'll just see and see what we might have to do to test this out. All right, here we go. Ooh, that's so cool. Yeah, it's not going slow. It's just adding a bunch of gas. Oh, wow. Yeah, that is pretty cool. Now we could add some more to this gas particle, like if we wanted the um how do we want to say? Maybe we don't want the gas to go. Let's see what happens here. Okay, add some water. Now add some lava. Cool. This is going to burn eventually, and that gas will just stay there. Now we could have a couple other properties. Maybe gas doesn't last forever. So maybe we want um, it to kind of disappear after a little bit. Um, let's see if we can do that. All right, so in our gas, we're going to have a float called gas time, and then a float gas. max, let's say it equals to 3. Let's name that max time. So let's say it gets through all this code and it didn't change its position. So it's in its same position. We're just going to say, we're going to start this timer. We're going to say, let's see, if gas max time, all right, sorry, if gas time is less than or equal to 0, then we're going to say gas time is equal to gas max. Else, so we are not less or equal to 0, we're going to say gas time is minus equal to time dot delta time. And then if gas time is equal to is less than or equal to 0, we're going to say simulation dot instance dot remove cell, and we're going to just remove this. So let's see if the gas particles will now just disappear. All right, so let's add lava. Actually, we could just test this with just adding gas. Actually, let's just do it. So here we're adding gas. Let's let go of it. Let's see if it all disappears. Yep, we can kind of see it slowly disappear. Now, these ones might never disappear because they never really get to a state of not being able to move, but eventually maybe it could do it. So we could, instead of um, doing something like this, where only when it's at a state of rest, it would start disappearing, we could just have a longer timer and remove the gas uh, slowly. Just remove slowly, no matter what, so it doesn't last forever. So I don't know if we should have something like that or not in our simulator, where we're removing gas. I don't know if that's how it should work, but we could do that. We could also do it where if it's clumped next to so many other gas particles, it changes back to water. Uh, Kind of like rain clouds almost. So if the more the more cells it's near that are gas particles, it would change it to back to water. So maybe let me know in the comment if you think I should do that with the gas or not. Here, let me just add this wall here. Just do like this and add water. Floats up. Eventually those will disappear. All this will just disappear. Yep. I think that's fine. But we could make it change to rain clouds. Or we change it back to water, and then we would just have an ongoing cycle. Here, let's maybe we'll try that real quick. So let's say it gets to this point where it's at rest, and maybe we want to kind of do a quick check if it's next to a certain number of gas particles. Let's think about how we might do this. So we want to get the cell position. So we're going to say cell. We could do a for loop for y is to 4, 3, for x is to 3. Actually, we want to start it with a -1 to a +1. Actually, 2. -1 to a 2. And we're going to say cell is equal to get cell was equal to simulation dot instance dot get cell. And we're going to get the cell from, let's see, where do we want to get that from? We want to get from uh, position plus new vector 2. Now, technically, we have all this stored, but it will be a little bit better to do it this way. Blah, 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 vector 2, x and y. So, oh, I didn't change this to x. So we're going to loop through all of them. All right, if cell is not equal to null, so we do have something there. If cell is not equal to this cell, so don't count ourself. If cell dot if cell dot cell type is equal to another gas particle, then we're going to, or we can just have a int total gas is equal to 0. We're going to say if we're going to say total gas is plus plus. All right. So now before we get rid of the gas, we're going to say if, oh, what in the world? If gas, if total gas is greater than, let's just say 6, right? 1, 2, 3, 4, 5, 6, 7, 8. We can say if it's greater than 6. We might want to actually hard code or not do this. Let's say int max gas, and let's just set to 6 for now. And then down here, now this is getting kind of long here, so probably I would want to maybe take this out. Matter of fact, let's just do that for the total gas for now. Let's just do this. We're going to make it into a method if it lets me. All right, I don't know what's going on here. Whatever. Control X. We're going to create a new private void check for rain. And let's call this max gas. All right. So now we're going to check for rain before we do this. Check for rain. And actually, we might make this a bool. So this is going to say return true. And yep, return false. Okay, so here we're checking. So now we can say if we check for the rain, and actually if we don't have rain, we're going to do the do the timer to get rid of it. But then here, so if we get to the max gas, we want to say kind of what we did with the water. We want to all right, grid, sorry, simulation instance dot, not instantiate, instance dot grid at our current position dot x comma position dot y. Let's make that null. And then we're going to say simulation.instance.remove. We're going to remove this cell. And maybe before we remove it, let's add simulation.instance.grid. Not grid, add cell. We want to use our current position, and we're going to add the cell type of water. All right, so let's see if this will, if as they're getting together, it's checking if it has too much. I'm not sure what this is going to do because there's no interaction with the water and the gas, and so maybe the water won't actually start dropping. We'll see what happens. All right, so I'm just going to add gas and see what kind of happens here. See if we ooh, I saw water. We got ooh. um I think I'm gonna get rid of the change that timer for the gas. Let's do something like this instead. Let's make a wall and let's fill this up with gas. Whoa, look at that. We got rain. That is pretty cool. I think what we need to do is uh that is pretty cool. So we got kind of a water system. Uh we could let's change the timer on that. All right, we are going to see if I change it to 10 seconds. So let's just add this little wall thing here. Let's add the gas. So you can see it's going to stop um, because none of this is, there's not enough gas particles next to it. We could maybe lessen that number and eventually it all goes away. I think that's fine. So it takes more than, you have to have quite a bit of gas to actually create that water. So we could, let's add a wall here. Actually, I need to make walls not. Here, let's do this. Let's just add this. Let's get rid of those walls there too. All right, we're going to add a bunch of lava here. We're going to have a walls going all the way down like this. Whoops. Okay. Well, we're going to see what happens here. And let's pour some water on here to fill this up with gas. And let's see if we can get kind of like almost an infinite loop, but probably not. Um, let's just see how long this water cycle will last in this. It's going pretty long. Um, Slowing down now. Now again, we could change it to where that's kind of cool. Uh, we're let's just add some more walls so it can't escape. We could change the number of particles for the gas. Um, we could do more with this. Um, but that's kind of cool. Yeah, so we got gas, change it to water. Water hitting lava, changing the gas, and so it has a little bit of a cycle there. Eventually, it won't get enough gas particles to continue the cycle. Now we could again not have gas disappear at all if we wanted to, and so it would continually do that. Let's just see what happens. Actually, it probably won't. The problem is we have to have enough gas particles in order for it to change back to water. So, but still, this time I'm adding more gas to it, and it's doing it. So that is pretty cool. And we're getting it everywhere. Everywhere it's raining. It's raining in our particle system. All right, so we now have gas added to our system. A little bit of a kind of water cycle. Um, how different particles can interact with each other and change the state of it, basically. I guess what we could add is next, I want to add some kind of like a intake pump system where we set a pixel and it's going to be like kind of like a pump, and anything that's next to it is going to suck that particle into the pump, and then it'll have uh, an out pump somewhere else, and so we can kind of create little fountains and stuff for our particle system. Anyways, thanks again for watching. I hope you're enjoying this. And if you have any ideas of what else we could add to this or how to make it better, just leave some comments. And as always, thanks for watching.